Good afternoon. Alright, well, I am going to be figuring out how to actually do multiplayer stuff with Unreal today. I haven't done any actual multiplayer client server stuff at all before, so at least with Unreal. So I have to figure out what we've even got, what we can do. So the first step to doing that is reading the freaking docs. So I'm just going to start reading. Is there a networking overview? That's what they're saying, as mentioned in the networking overview. Alright, I guess. Okay, so let me do that. Alright, the UE4 framework was built on multiplayer gaming in mind. As long as you know the basic conventions, you don't have to do much to extend single player experience to multiplayer. Well, that's just bullshit. It's always a pain in the ass. Alright, so networking is built around client server model. Alright, so I'm going to be basically making this diagram at the same time here. Alright, so UE4 is built around the client server model. This means there will be one server that is authoritative, makes all the important decisions, and this server will then make sure all clients are continually updated. Okay, so server is server authoritative. So I guess we basically got this server that's going to be doing its thing here. So let's see, why don't I... Do we have like an arrow? I want to like a... These are stupid. I need a better shape. I want like a little circle with some arrows going in a circle. Who cares? We'll just make our own little shape. Alright, so this thing is going to continually update, and we are going to connect to our client, and all of our clients connect to this server. Alright, even non-network single-player games have a server. The local machine acts as a server. Okay, so there's always a server. In a single-player experience, actors are used to represent the game world. In multiplayer, this isn't any different, except for the fact that clients have an approximation of each actor, while the server will maintain an authoritative version. Actors are the main workhorse of servers used to keep the client up to date. It's necessary for the server to update a particular client. The server will gather all relevant actors that determines a change since last update and sends that information to the client to catch all those actors up to date with decent state. Okay, so we've got a whole bunch of actors. And every tick, we've got these, I guess, we will replicate these things every so often or whatever. So alright, when it is time for the server to update a particular client, the server will gather all relevant actors. Alright, so some of the questions. How often is this sent? I don't know. I'll have to figure it out. So networking types, there's standalone, dedicated server, listen server, and client. Type indicates a server is a local machine not accepting clients, best for single player or local multiplayer games. Dedicated server has no local players, can run more efficiently by discarding sound, graphics, input. Alright, so the listen server is a server that hosts a local multiplayer but is open to connectors from remote players as well. This type of server is good for competitive or cooperative games where a dedicated server is unnecessary. And then client, this is the only mode that is not a server. When in this mode, the local machine is a client to a dedicated or listen server and therefore will not run server-side logic. Alright, so we need, for this game at least, we're going to want dedicated server support. But it looks like we have kind of two modes, because we want to be able to actually, we want people to be able to host their own stuff and have dedicated servers. So it sounds like okay, so I'm guessing, like, we definitely want this. So this is what, so I guess we'll have to figure out exactly what all this means with the game modes and like where we need to set them and everything like that. Alright, so that's the overview. So actor replications. As mentioned in the networking overview, actors are the main workhorse for replication. Server will maintain a list of actors and update the client periodically, so the client will maintain a close approximation. They're updated in two ways: property updates and RPCs. Alright, so we've got these RPCs and all this stuff. So I guess these actors actually... So what actually calls the main difference between a property replication and RPCs is that properties are replicated automatically anytime they change, while RPCs are only replicated when executed. Okay, so we have RPCs on the client and the server, is what it sounds like. I mean, obviously there's going to be some sort of duplex communication here. So I'm expecting I'll be reading at some point here that there are client and server RPCs. Alright, so a good example of a type property that should be replicated is an actor's health. This is something you likely change. The health value isn't changing, nothing will be sent. Pretty efficient. Keep in mind, even though the property isn't changing, there is still CPU overhead in determining whether or not it is changed. So things that change often use property replication. Alright, so for replication, there are properties. Alright, so These are best used for things that change all the time. Sent every time it changes. Okay. For more information about properties, see property replication. An example of an RPC might be an explosion. You want each client to see it at a certain location. You declare an RPC that takes position and radius as parameters and call that each time an explosion occurs. This stores a group of properties that replicate to indicate to the client, but that's less efficient since explosions might not occur often enough to justify these being properties. Alright, so RPCs, these are best for triggering events. Think things that don't happen often, like a character dying if you can't see its health or whatever. For information about RPCs, see the RPCs documentation. Alright, so we'll look at properties. Each actor maintains a list of properties that can be marked for replication to clients. Whenever the value of the variables changes on the server side, the server sends the client the updated value. Alright, so the server sends the client the updated value. Does that mean it doesn't send what it was? Doesn't send what it was? Does it send diffs? That's a question. Property updates only come from the server. The client will never send property updates. Yeah, okay, so the client will never send updates or properties to the server. Alright, that makes sense, I guess. Some properties replicate by default, like location, rotation, who owns them. These properties that the framework generally depends on to make multiplayer work. From there, you can mark additional properties to replicate as needed. To replicate a property, you need to do a few things. In the header of the actor class where the property is defined, you need to make sure you have a replicated keyword as one of the parameters to the property declaration. Okay, so let's see. Let's have replication in practice. Properties. So it's mark properties on actors with replicated. In the implementation of the actor class, you need to implement the get lifetime replicated properties function. Okay, you also have to add a get lifetime replicated props function and add the actor. You also need to set b replicates equal true inside the actor's constructor. So we gotta do 3 things, otherwise multiplayer just doesn't exist. Okay, so if you do those 3 things, your property will be synchronized to all clients for every copy of the actor type is currently instantiated. Actors will observe a maximum update frequency set in the net update frequency variable. Alright, so actors have a net update frequency variable? Common update frequencies are 10, updating every 10 times per second. Okay. This is how many updates per second. Recommended to be 10. For important unpredictable actors like player-controlled characters, 5. Alright, so 10 for fast, 5 for slow. For background, it's not very important, but they're still synced over the network and thus need replication. Is this on a... so... okay. Alright, so actors have this specific net update frequency thing. Alright, so there's an active network update frequency as well, which is when this feature is enabled, the system will dynamically adapt the update frequencies from individual actors based on their updates. Each actor's possible range of update rates is determined by net update frequency and min net update frequency. Net update frequency indicates the maximum number of times, while min net update frequency indicates the minimum number. Using this feature can result in massive replication performance improvement. Okay, so turn on adaptive network update frequency and set the min to the floor for how often we replicate stuff. That should be specific. Replicate property values. Update frequency decrease algorithm. During update attempts, actors store how long it has been since the most recent record the time. Blah, we don't really need that. Update frequency increase. After sending a meaningful update, an actor will schedule the next update to happen in 30% less time. Alright, so there's just like a whole bunch of crap you can do with different updates. Alright, so let's go to RPCs. RPCs are functions that are called locally but executed remotely on another machine. RPC functions can be very useful, allowing either the client or the server to send messages to each other over the network. Alright, so RPCs are sent from the client to the server and vice versa. Let's update our picture here. So RPCs are dual. So we can call both ways. So let's see. RPCs are sent from client and from server. And then properties are only sent from the server to the client. Alright, so client actors have got like so properties. Alright, so actors themselves are the thing. So it's property update frequency is controlled on the actor level. So you can't have like a property that updates itself a whole hell of a lot, I guess. Okay, the primary use case for these features for RPCs are to do unreliable gameplay events that are transient or cosmetic. These include events such as play sounds, spawn particles, or other temporary effects that are not crucial to the actor functioning. Previously, these types of events would often be replicated via actor properties. When using RPCs, it's important to understand how ownership works, since it determines where most RPCs will run. To declare a function as an RPC, you need to simply add server, client, or net multicast keywords to the U function. Okay, so we've got a few things to work with. So RPC, there are different types. There are client RPC. There are server RPC. And there are net multicast RPC. So what are these? To declare a function, use the server keyword. Alright, so to declare a function as an RPC that will be called on the server but executed on the client. So this is called on the server to execute on the client. Do they mean, is this all clients? Is question. Server. To declare a function as an RPC that will be called on the client but execute on the server, use the server keyword. This is called on the client to execute on the server. There's only one server. There's another special type of RPC called multicast. Multicast RPCs are designed to be called from the server and executed on the server as well as currently connected clients. Alright, so this is called on the server and executed on all clients and the server. Alright. Notice how we prepend client-server multicast keywords at the beginning of a function. This is agreed upon convention. Okay, so always prepend RPCs with client, server, or multicast. Makes sense to me. This is very useful for determining at a glance. Sorry. There are a few requirements that need to be met for RPCs to be functional. They must be called from actors. Okay. RPCs must be called from actors. The actor must be replicated. If the RPC is being called from the server to be executed on a client, only the client who actually owns the actor will execute the function. Okay, so client RPC, only the client who owns the actor will execute this function. If the RPC is being called from the client to be executed on the server, the client must own the actor. Okay, so only the client must own the actor which has this RPC. Multicasts are an exception. If they're called from the server will execute them locally as well as execute them on currently connected clients. If they're called from clients, they'll execute locally and will not execute on the server. Alright, so if called from server, all clients and server execute RPC. If called from client, only that client executes it. For now, we have a simple throttling mechanism for multicast events. The multicast function will not replicate more than twice in a given actor's network update period. Long term, we expect to improve on this, especially cross-channel traffic management throttling. A multicast function will not replicate more than twice in a given actor's network update. What? That seems like a real nasty thing. I guess. Okay, so multicast events may not execute one-to-one? I don't understand this. A multicast function will not replicate more than twice in a given actor's network update period. So if we are updating 60 frames per second and we call something every second, and we're on 10, we're only going to execute at a maximum of 10 times per second, even though we called it that many times. It's not really an RPC then. Like RPC is, I would imagine we'd be getting a response. Yeah, by default they're unreliable. To ensure that an RPC call is executed on a remote machine, you may specify the reliable keyword. Alright, so alright, so they can be reliable or unreliable. Okay, that makes sense. They run the maximum. They run a maximum number of what was the name? Net update frequency on the actor. To make an RPC reliable, specify reliable on the function. Do we get responses from anything? Like, can we get a response from an RPC, or is it just, I don't see any sort of response, like to know something's executed. Functions that are marked as RPCs will also be replicated if called from blueprints. In this case, they will follow the same rules as they're being called from C++. It is not possible at this time to dynamically mark functions as an RPC from blueprints. Custom events, however, can be marked as replicated from within the blueprint editor. Right. Recently, the ability to add validation functions to RPCs was added to serve as a choke point for detecting bad data or inputs. The idea is the validation function. Okay, so we can add validation functions which will check the input for bad data. So why is this there? I guess just to make things stop things from freaking out. Alright. This will disconnect the caller. This will allow the RPC to be... Ooh. Okay, so we can just like... A return of false will DC the client connection. Alright, I guess that's what you want. Like you send the wrong variable, then get the hell out. More recent changes added to UHE to require client server. Okay. So, client to server RPCs must have a validate function. And that's just to encourage secure server RPC functions and make it easy as possible for somebody to add code. Alright, so they basically tired of people getting their games hacked to shit, so they just said, alright, you have to at least put something in here, otherwise you won't compile anymore. Alright, so we got actor replication. So I'm gonna change this a little bit here. I'm gonna make this line like that. Alright, so that's how I'm going to do that. So we have the validation for RPC calls on there. So that's where we've got kind of our network security layer. Alright, so let's take a look at components. Unreal 4 supports component replication. While it's straightforward to use, it's not common. Most components do not replicate. Most game logic is done in the actor class, and components usually represent smaller pieces that make up the actor. That gameplay logic in the actor is what replicates, and its results sometimes end up in calls changes to the components. However, cases exist where properties on or events on components themselves need to directly replicate. Components replicate as part of their actor. The actor dictates role, priority, relevance, culling. Once the actor is replicated, it may also replicate its components. These components may replicate properties and RPCs in the same way an actor can. Components must implement a getLifetime replication properties function the same way actors do. Alright, components can also have replication. They must specify the function to do so. They probably also need the exact same they probably also need, this replicated thing. So that's one thing to make sure. Make sure that if a component is replicated, that the actor itself has the proper setup, as if it doesn't, it won't work. There are two broad categories of components when talking about actor replication. Static components are components that are created when the actor is created. That is, when the owning actor is spawned on the client or server, these components are also spawned, whether the component is replicated or not. Alright, so static components are spawned as you'd expect. The server does not tell the clients to explicitly spawn these components. In this context, static components are components created in C++ constructor and the deep blob. Static components do not need to be made to replicate to exist on clients. They exist by default. Dynamic components are components spawned on the server at runtime and whose creation and deletion replicate down to clients. They work very much in the same way actors do. Unlike static components, dynamic components need to replicate to exist on clients. Alternatively, clients can spawn their own local non-replicating components. This is actually fine in many cases, as only when properties or events that trigger on the server need to be automatically synchronized to clients does replication come into play. Setting up properties and RPCs on components works the same as the actor. Once a class is set up to replicate things, the actual instances of the components must be set to replicate. To make a component replicate, simply call actor component set is replicated. So set is replicated to true. There's also a set net addressable. Alright, let's just have a little open questions thing down here. What the fuck is that? Okay, to make static blueprints replicate, simply toggle the replicates bool in the components. This is only done in components. Note that not all components will show this, only ones that support replication. Timelines having a replication. Alright. The overhead for component replication is relatively low. Each component within an actor that replicates will add an additional 4-byte header and approximately 1-byte footer along with its properties. CPU-wise, should be minimal. Alright, so that's not too much. In that GUI for generalized sub-object replication. All actor sub-objects can replicate, not just the components. The application is very narrow. The interface is instant. Alright, wait, what? Replicate sub-objects. Method allows an actor to replicate some. Alright, so replicating sub-objects is tricky and requires handling sub-object replication. You have to do it yourself. That's gross. Updating in your actor's CPP. Alright, so previously replication of complex data structures always restrict the structures whose type is statically defined. Right. In case of having many sub-objects to replicate, an actor can save a lot of time by knowing which, if any, sub-objects have recently changed and need to be replicated. This means keeping track of sub-objects changing through access functions. The interface for doing this is in the UActor channel, so key needs to replicate. The function should be called the actor replicate sub-objects implementation. Alright, so you can, if you have a whole bunch of sub-objects, there's optimizations you can do to not have to replicate things. So there is a key needs to replicate. So you can implement key needs to replicate function yourself. Okay, makes sense. Okay, so actors and their owning connections. You'll hear a lot about owning connection of an actor. Ultimately, each connection has a player controller created specifically for that connection. Each player controller that is created for this reason is owned by that connection. To determine if an actor in general is owned by a connection, you query for the actor's most outer owner, and the owner is a player controller, then that actor is also owned by the same connection that owns the player controller. Alright, so let's see, we've got, let's make a thing over here, let's call it object ownership. So if we've got this client, we've got a player controller, and then we have any owned objects. Owned objects, or they owned actors? They're owned actors. So we have them like this, and this is a connection on the server. It looks something like this. Actually, I guess more specifically, this is from the so that's kind of how these things work. Okay, so each player controller is created for a reason, is owned by that connection. To determine if an actor is owned by a connection, you can query the actor's most outer owner, and if that owner is a player controller, then the actor is owned by the same connection that owns the player controller. Okay, so let's just write down object ownership. To determine who owns an object, follow its parent, its owning actors all the way up. If it's a player controller, then it's owned by that connection. Alright, another example. Alright, one example is where upon actors are possessed by a player controller, their owner will be the player controller that they are possessed by. During this time, they are owned by the connection of the player controller. The pawn is only owned by this connection during the time that is owned or possessed by the player controller. So as soon as the player controller no longer possesses the pawn is no longer possessed. Alright. Inventory items that are owned by a pawn. These inventory items are owned by the same connection that might own that pawn. Okay, so if we have an actor, and that actor owns things, and we possess that thing, then we get everything under it. Components are a little special in how they determine their owning connection. In this case, we first determine the component's owner by walking the component's outer chain until we find the owning actor, and we continue above by determining the owning connection of this actor. Alright, well, yeah, it's all based on actors, so that makes total sense. Connection ownership is important for a few things. RPCs need to determine which client will execute actor replication and therefore relevancy, and actor property replication conditions where the owner is involved. Connection ownership is important for things like RPCs. When you call an RPC function on an actor, unless the RPC is marked multicast, needs to know which client to execute on. Connection ownership is used during actor replication. determines which updates get to which actors. For actors that have be only relevant to owner set to true, only the connection that owns it will receive updates from this actor. Okay, so if only a specific client needs updates to an actor, set the be only relevant to owner in the actor's constructor. That makes sense. By default, all player controllers have this flag set. Okay, that's something to know. The be only relevant to owner is auto set on player controllers. And that means everything under it? Yeah, okay, so the player controller, that's weird. I would have thought that. Okay, that's a good plan. So it's things that are under the player controller that we replicate, not the player controller. So connection ownership is important during property replication for that is the owner. For example, where cond only owner is used, only will receive these property updates. Okay, so there is conditional property replication. Alright, interesting. I'll have to read up on that in just a bit. Alright, lastly, the owning connection is important for actors that are autonomous proxies. For these actors, their role is downgraded to role simulated proxy while their properties are replicated for connections that don't own these actors. I don't know what the fuck that means. I don't know what the hell an autonomous proxy is supposed to mean. I'll have to figure that out. Alright, so conditional property replication. Once a property is registered for replication, you cannot unregister it. Alright. Once registered, don't tell me what I can't do. For property replication, you cannot unregister that property. The reason for this is because we bake in as much information as possible so we can take advantage. Alright, so bullshit justification, this saves time. Yeah, okay, hand wave. We do this for reasons. Alright, so how does one get more fine-grained control? Why are you asking questions to me, documentation? You should be telling me, not asking me. That's where conditional properties come in. Alright, whatever tech writer, I think when he was writing this article, he spent way too much time in high school English class, just in general. By default, each replicated property has a built-in condition, and that is that they don't replicate if they haven't changed. Alright, just fucking tell me properties don't replicate if they haven't changed. Then I read like 5 words instead of 20. To give you more control over how a property replicates, there's a special macro that allows you to add a secondary condition. This whole article reads like a stenographer took it down while somebody was explaining to somebody else very slowly. This macro is called doReplicateCondition. An example of usage is below. Okay, so conditional property, like the thing is, the picture here is actually giving me more information. Like, these words don't mean jack shit, but when he actually puts like, okay, you have to specify replication conditions inside of the replicated props function. Like, that's all I needed to know. So conditional replication properties or replication settings are set up in get lifetime replication properties. The condition simulated only flag that has been passed in the condition macro will cause an extra check to be formed before even considering this property for replication. In this case, it will only replicate to clients that have a simulating copy of this actor. Okay, so you can specify if things get sent by simulated only and updates only be sent to clients that have a simulated form of the actor. One of the big benefits is saves bandwidth. Alright, yeah, just, I get it. It's real obvious. Here's a quick glance at the listing of initial only. The property will attempt to send on the initial bunch. Owner only, skip owner, simulated only, autonomous only, simulated or physics, initial or owner, or custom. Alright, so properties can be sent only to the actor's owner, sent to everybody except the owner, simulated actors, autonomous actors, rep physics actors, initial only, or to the actor's owner. Like, why aren't these just bit fields? And we just do ors, and like, why are they combined? That's stupid. This property has no particular condition, but set custom is active override. Okay, so they've got overrides for things. I'll just say there are many switches for what can be replicated automatically. And there is a custom replication override because reasons. Interesting. So far we've talked about conditions that are based off the state that is already known. This makes it easy for the engine to make necessary optimizations while still giving you enough control. What if it isn't enough control? Jesus Christ, I don't care. There's one more thing to talk about on this. Like, just drop that sentence, please. Do replicate active override. Property does not anything. So there is, it's per actor, not per connection. It's not safe to use a state that can change per connection or custom condition. Example might be something like this. Okay, so you can also override the, yeah, you can override it. Okay, cool. Why not use macro? There are two main reasons. It's alright, property of, yeah, whatever. That article sucks. I need to rewrite that. Alright, actor relevance and priority. A level can be huge, and a time a player can only see a small fraction of the actors in that level. Most of the actors in the level are not visible and are not audible and have no significant effect on the player, obviously. The set of actors that determine that the server deems, yeah, it's perception filtering, are visible to capable significant bandwidth. Alright. If the actor is always relevant. Alright, so these actors are implemented in the virtual function is net relevant for. Alright, so net relevancy. You must specify your net relevancy in the is net relevant for function. Okay, so it's always relevant. Alright, if the actor is always relevant, is owned by the player controller, is the pawn, or the pawn is the instigator of some action, it is relevant. Okay, they just like, they're using programmer logic in English sentences, which doesn't really work. I'd rather see the code than the damned English that code could be represented as. If the actor is B net use owner relevancy and has an owner, is the owner's relevancy. Only relevant to owner. Alright, so if the actor is attached to the skeleton of another actor, then the relevancy is determined by the relevancy of its base. If the actor is hidden, if there is no root component, actor is net relevant for. A game network manager is set to use distance-based relevancy. The actor is relevant if it is closer than the net call distance. Alright, so you can control relevancy using a game network manager object. This is for distance relevancy. And otherwise, doesn't look like anything is on the component. Alright, so the distance check can sometimes give false negatives with large actors. The approximation is such that this error is overwhelmed by the error inherent in the network environment. Unreal uses a load balancing technique that prioritizes all actors and gives each one a fair share of the bandwidth based on how important it is to gameplay. Each actor has a floating point variable called net priority. The higher the number, the more bandwidth the actor receives relative to others. An actor with 2 or whatever will be updated exactly twice as frequency as an actor with priority of 1. So obviously you cannot improve Unreal's network performance by increasing all the priorities. Everything gets a priority of 11. Alright, net priority. You... So... Some of the net values are the current priority of an actor is calculated using getNet priority. You must implement the getNet priority function. This is then multiplied by time to prevent starvation. Alright, so it's basically a hint. You can't really do too much with the priority. You can't be like, well, you know, this has a priority of a bajillion. It'll get multiplied by time. So you can kind of massage it a little bit, but it's not like you can completely discard stuff entirely. Alright, the bulk of actor replication happens inside of server replicate actors. This is where the server will gather all the actors as determined to be relevant for each client, since any properties have changed since the last time each connected client was updated. This is defined flow and how actors are updated. Okay, so important ones are... Alright. Well, I'm going to be right back. I need to get some water. And this is reading documentation, the stream. Alright. There's a defined flow in how actors are updated. Certain framework callbacks that are invoked or certain properties used during the process. The important ones are net update frequency. Alright, so let's just see replication details or replication settings. Replication things. Net update frequency. This is how often the actor replicates. We've got pre-replication. So this is called before any replication happens. This is on the server. Is this only on the server? The bulk of it happens at server replicate actors. What about clients? I mean, the client's gonna be sending stuff, right? No. Replication only goes from server to client. RPCs go the other way. B is relevant to owner. Is relevancy owner for. Is net relevant for. Alright. The higher level flow looks like this. Look over each actor that is actively replicating. So set replicates to true. Alright, so there's like initially dormant. Let's just see overall rep nodes. Things can be dormant. Short the actor needs to be activated, check net frequency, if not skip. Check if it's relevant. Pre-replication is a place where you can decide if you want properties to replicate for connections. Use the do rep lifetime actor override for this. If we pass above, okay, so we can override some things. For each connection, for every actor, determine if it's dormant. Determine if there's a channel. Basically, if we can actually send anything. For each sorted actor, if the connection hasn't loaded, close the channel. Replicating an actor. Alright, so replicate actor is the workhorse. So we have channel, replicated actor. Determine if this first update, serialize specific information. So there's a special delete command and all these other things. We replicate each component's change properties. So actor properties, component properties, deletes. What about ads? Jesus Christ. Alright, performance and bandwidth tips. Replicating actors can take time. The agent does its best to make it as efficient as possible, but there are things you can do to make this job easier. The server will check a few things like relevancy. You can tweak any of these. You can turn off replication. So you can toggle things on and off. You can lower frequency, you can set dormancy, relevancy, and yeah, okay, so basically performance, they're just like, use the damn tools please, read the manual. Alright, so don't use F names, don't use strings as things, alright. Don't send strings. You can, they get sent as strings. Yeah, that's true.